Now I want to ask the question, how many different groups of size R can I select from a total of n items if order doesn't matter? In other words, if I choose A, B, C, B, A, C, or C, B, A, or whatever, it doesn't matter what the order is. It's just a group of 3 letters. All right, so I'm looking for a group. How many different groups where order doesn't matter? So we're going to go ahead and look at some different situations. I want to start with how many ways are there to choose blank letters out of 2. So I have 2 letters, and so imagine I have these 2 cubes with letters on them. A cube with letter A on it, a cube with letter B, or maybe a ball or a circle or a chip or something. Something I can pick out of the bag. So I think, how many ways can I get 1 out of 2? So if I pick in my hand in the bag and I get one thing out of the bag, it's either an A or it's B. So I have 2 different possible outcomes for picking 1 out of 2. I could get an A or I could get a B. So there are 2 things I could get. How many ways could I get a 2 out of 2? It would be an A and a B, and it doesn't matter what order they're in, so there's only one way to get a handful that has both letters. Now let's go backwards. How many ways are there to get 0 out of 2? Well, you might think 0, but really what you're thinking of is how many possible outcomes are there when I reach in my bag and get nothing? Well, there's one possible outcome, the outcome of getting nothing. So there's only one outcome here for 0 out of 1. So now that we've kind of defined what that means, let's go backwards. How many ways if I only have 1 letter in the bag, how many ways are there to get 1 out of 1? Obviously 1. How many ways to get 0 out of 1? 1. So basically I have a single outcome of getting either nothing or getting 1 letter. Now, if I don't have anything in the bag, how many ways are there? How many different outcomes do I have? I have 1 outcome. I'm not going to get anything. So there's 1 outcome for 0 out of 0. Okay, so let's go to the more interesting ones. We kind of laid the foundation here. Now we have the letters A, B, and C. So how many different ways are there to get 0? Okay, 1 way to reach in my hand and get nothing. How many outcomes are there if I reach in my hand and pull out 1 letter? Well, I could get an A, I could get a B, or I could get a C. So there are 3 possible outcomes. Now, how many ways are there to get 2 out of 3? Well, I could grab an A and a B, I could grab an A and a C, or I could grab a B and a C. Remember, order doesn't matter, so it doesn't matter whether I get a B and an A or an A and a B, it's the same thing. So once again, there's 3 different ways to get 2 out of 3. How about 3 out of 3? I reach in my hand, I get 3 letters. I'm going to get these 3 letters, A, B, and C. One possible way to do that. All right, look at 4 now. So 4, we'll have to do a little more thinking on this. How many ways to get 0 out of 4? 1. How many ways to get 1 out of 4? Well, I could get an A, I could get a B, I could get a C, or I could get a D. There are 4 possible outcomes. We're picking 1 letter. Picking 2 letters. Now we have to think about this a little more. I could get an A and a B. I could get an A and a C. I could get an A and a D. Or I could get a B and a C, or a B and a D, or a C and a D. Now, how did I figure this out? First of all, I paired up A with every possible letter. A could go with B, could go with C, could go with D. A's done now. So now pick B. B's already gone with A, but B could go with C or D. Now B's gone. C's already gone with B, C's already gone with A, so C could go with D. So I have 6 different choices, or 6 different possible combinations of 2 letters that I could get out of a bag with 4 letters in it. Now, how many different combinations of 3 letters could I get out of a bag of 4? Well, I could get A, B, and C. I could get A, B, and D. I could get A, C, and D. Okay, so A's gone with B and C, B and D, and C and D. I'm done with A. I could also get B, C, D. Now, you might think, how do I know when I'm done? Well, think about each time I've left out a letter. So this one has no D. There's no D in this one. This one has no C. This one has no B. And this one has no A. So there's 4 different ways that I can leave a letter out. So there are 4 possible outcomes for drawing 3 out of 4 letters. How many ways are there to draw 4 out of 4? Well, I'm going to get all 4 letters. There's only one way to do that, A, B, C, D. Okay? So, to be consistent, here's my arrow. That looks stupid. I'll just take that off. Take off the arrow. Okay, so here are my possible outcomes for getting a certain 0, 1, 2, 3, or 4 out of 4. Now you can see that if I kept this up, like how many letters out of 5, out of 6, we'd start getting these really long involved lists and it would get kind of cumbersome. So I'm going to show you a mathematical formula for figuring this out for any number. It's called a combination. You write it like this: n, little n's as a subscript, big C, little r as a subscript. And we read this combination of n select r, or the number of ways to select r individuals from a group of size n. And remember, this is one where order doesn't matter. Unlike the permutations, which definitely meant order, order doesn't matter with combinations. So before I write the formula, I just want to remind you again, it's going to include factorial. So n factorial means, for example, 5 factorial. Not that I'm super excited about 5, but it means 5, 4, 3, 2, 1. Multiply them together, 120. Also note that 0 factorial by definition is equal to 1. And that's equivalent to what we were talking about. How many outcomes can I get when I have 0 items? There's 1 outcome. All right. So here's what the formula is. Drum roll, please. Okay. If you've ever seen what is it? The Griswold Christmas, I forget what it's called. Anyway, whatever that movie's called, and they all do the little drum roll with their tongues. Okay, silly example. All right. N factorial over n minus r factorial times r factorial. So we have a factorial in the numerator and we have 2 factorials in the denominator. So here's where we see the n. We see that in the numerator. And then we subtract the 2 here. We see that right here. And then the r we see right here. So we have n in the numerator. We subtract the 2 numbers. That goes in the denominator with a factorial, and then the second number with the factorial. So let's apply that to our examples that we just did with our 4 items. So we had 4 select 0. How many ways can I select 0 out of 4? Well, in the numerator, I'm going to write 4 factorial. The denominator, subtract those 2. 4 minus 0 factorial times 0 factorial. So this would simplify to 4 factorial over 4 factorial times 0 factorial. Well, I could write out 4 times 3 times 2 times 1 in the numerator and 4 times 3 times 2 times 1 in the denominator, but hopefully you realize that 4 factorial divided by 4 factorial is just 1. And 0 factorial by definition is 1, so I end up with 1 over 1, which is 0. Or sorry, which is 1, not 0. Okay, so 4 select 0, there's one way to get that. Let's do 4 select 2. 4 select 2. So if we do 4 select 2, we get 4 factorial in the numerator. In the denominator, we have 4 minus 2 factorial times 2 factorial. So 4 factorial over 2 factorial times 2 factorial is 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. So what cancels out? 2 times 1 and 2 times 1. What do I have in the numerator? 12. In the denominator, I have 2. So we get 6, which is exactly what we expected to get from what we had done up here when we listed and counted them. So these are, now some of the smaller ones, it's pretty easy to list and count. But for larger numbers, this is really, really helpful. So let's do our horse example. So instead of wanting to get how many orders they can get first, second, third place, let's just say I want to select a group of 3 horses out of 10. groups. Right. Select a group of 3 horses out of 10. So I'm going to say 10, select 3, which is 10 factorial over 10 minus 3 factorial, 3 factorial. So this is 10 factorial over 7 factorial, 3 factorial. So I'm going to write out my numerator. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 7 times 6 times 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. Now, you might recognize that once you get to 7 and below, 7 factorial is 7, 6, 5, 4, 3, 2, 1, all multiplied together. And when I get down to 7, 6, 5, 4, 3, 2, 1 in the numerator, I could have just written, oh, this is just 7 factorial and this is just 7 factorial, and they're going to cancel out. So all of this, actually, I'm going to put it in a different color. All of this is just 7 factorial. And all of this is just 7 factorial. So I could have just written 10, 9, 8 times 7 factorial and left the 7 factorial in the denominator. But all of these are going to divide out. 7, 6, 5, 4, 3, 2, 1. All right. Now that leaves me with 10 times 9 times 8 in the numerator and 6 in the denominator. I can just multiply that out and do 720 divided by 6. And actually, I think I will. Let me just do that. 720. Let me write it over here, equals 720 divided by 6. So let me tell you the significance of this. When we did how many different ways can we get first, second, and third place with 10 horses, we got 720 different ways. But how many ways can you rearrange first, second, and third place? Well, that's 3 items. So there's 6 different ways to rearrange, get different orders with 3 items. I don't need the order now. Order doesn't matter. So I divided out the order. The order doesn't matter. So now 720 divided by 6 is equal to 120 different ways that we can get 3 horses out of a group of 10. This is going to allow us to make it easier for us to count outcomes in a little bit more complicated situations.